Okay, so we're back at part two, data partitioning and test. This is a pretty easy spot or easy thing to do in concept, but getting this right is a big deal. So most of the documentation I read online shows this in this format, and the idea here is to get 80% of your labeled set before and then you basically separate them out like from a labeled set to a feature set so that you're getting 80% of both of data sets. So if you could imagine a sparse data set, if you just did 80% of the whole thing, you likely wouldn't get a lot of labeled rows. So this is a big deal to get this one right. Pandas make this kind of nice and easy. So this panda concat is like a join, and so that's really what's going on there is you take these two data sets, join them together. Now you've got the train set, and you take the inverse of that to get the test, the ones that aren't used. And similar for your label set. This is just a little cleanup. You don't have to do it that way. I just did. Okay, so then now the fun part, the neural network setup and training. So here we'll go through and set up our labels. And so this is after the feature engineering we just talked through of going through all the graphs, coming up with here's our list of correlated variables we think. This one actually has some that aren't correlated. I just put them in just to show you that it'll still work even with not so great features. But this is the place you put them in. Oops. And then here, this bucket command. This is for any of the category labels, like ACI response. This is showing you like here's all the values. You remember on the histogram, those were the integers that the data was congealing around. So to show you all the values, it's kind of a fun little command. Here's getting into the meat of it though. So here's the helper function. You can find this up on the TensorFlow website, but this helps with making the tensors for the continuous and the categorical columns. I had to modify this a bit to get this iterator to work through it, but anyway, it's how we get the tensors built. And then this is the estimator or a classifier. This is just kind of an if then that says, hey, if it's wide, use linear, deep, DNN, and then the combined. The next is something I use. You probably don't use this, but this is just where the TensorFlow files will go. I just always forget the directory. And here's the main execution block. So here you can set the settings of deep, wide, and deep and wide, and your steps. So this is an important one. And the step above it, I forgot to mention, you can also change your hidden units. You can change these numbers to change the network design. And then you'll notice here I'm slicing the training sets and the label sets, and that's just for speed of the demo. Generally, you'd take these off, but it would take about an hour to run, or probably 10 minutes on a wide, but at least an hour, maybe 2 hours on deep. So I just set them to a small, small training sample. So anyway, so we're looking through. It's still running. Notice the kernel's still running here, so it's already at 94 something. So it's already doing pretty well on the deep. So while we wait for that, I'll go back and get through the results. But for the wide accuracy, we had 99.92% accuracy. Deep was 99.17, and so same for wide and deep. Those are the ones I have documentation for. When I ran the wide and deep fully with the full kind of everything set correctly, that took a few hours to run, and the accuracy was like 9.9 something. So it was good. But on the small data sets, they actually perform the same. I'm not sure why they had the same accuracy. They actually had different loss. So that's interesting. So, and then I'll get to this visualization in a minute when the deep networks is done. But the summary of it is that TensorFlow demonstrates a strong feature set and is able to solve the chargeback classification problem pretty concretely. A serious investment in corpus development is required to obtain the high accuracy. Partition strategy, along with hyperparameter tuning, is also a very big consideration in accuracy, and then most importantly, processing speed. So the demo application, when extended, would be perfectly capable of solving this classification problem. And I would just note up here, this is what you'd call. So once you've trained your set, you can call this one to do individual. So if an individual transaction came in, you could envision, say Spark streaming or some sort of mechanism that basically is calling this evaluate on transactions of flight to give you a prediction of what's going on. So our model's done here, and we got 99.9973. So pretty good, a little bit better. Maybe a little bit worse than the last time. No, this is better, a little bit better, because this was a deep model. And then down here, you can run TensorFlow from the command. Right from here, I used to go to the command line, but this is kind of a neat little trick. You can just click go here, and it'll start running TensorBoard. I'm not sure why that dim was like that, but so the TS&E is really amazing. It's pretty mesmerizing to watch. I let it run for a while, and it basically does a good job of starting to group these things together along some sort of axes, and I haven't quite figured out what it is, but you let it run long enough, and you'll start to see these dots congealing on the page. But I'll let you guys play with that when you download the code. So anyway, in summary, the product works, and I do recommend these books. This Hand-On Learning, Scikit and TensorFlow, the TensorFlow cookbook, and these tutorials were very helpful to me as I was going through the project. So anyway, I hope you really enjoy the video and the demo and the application, and look forward to any questions that may come up.